Hello guys, welcome to my YouTube channel Upsc Cse Insights with Subhash. Today our video is about second topic of Yojana Magazine analysis. The topic is Voyage to study the Earth's sun. Voyage means long journey involving travel by sea or in space. Let's dive into the video. Aditya L1 is the first space-based Indian mission to study the sun. Through various orbit raising maneuvers and the cruise phase over about the next 4 months, the spacecraft shall be placed in a hollow orbit around the Lagrange point of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. Here, the maneuvers means a large-scale military exercise of troops, warship, and other forces. And then the spacecraft carries 7 payloads to observe the photosphere of the Sun. Here the photosphere is the first layer of the Sun, and chromosphere and the outer layers of the Sun using electromagnetic and particle and magnetic field detectors. While coming to this paragraph, the spacecraft of Aditya L1 carries 7 payloads to observe the photosphere, chromosphere, and the outer layers of the Sun using electromagnetic and particle and magnetic field detectors. The Sun. Our Sun is the nearest star and the largest object in the solar system. We all know that. The estimated age of the Sun is about 4.5 billion years. It is a hot glowing ball of hydrogen and helium gases. The distance to the Sun from the Earth is about 150 million kilometers and is the source of energy for our solar system. Without the solar system of the Earth, as we know, cannot exist. The gravity of the Sun holds all the objects of the solar system together. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. At this temperature, a process called as nuclear fusion. Nuclear fusion takes place in the core which powers the Sun. Here the nuclear fusion means it is a process in which two or more light atomic nuclei join together to form a heavier nucleus, releasing a huge amount of energy. This takes place in the core of the Sun. The visible surface of the Sun, known as photosphere, is relatively cool and has temperature of about 5500 degrees Celsius. While coming to the Aditya L1, it is the first space-based observatory class Indian solar mission to study the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any occultation or eclipse. Here the occultation meaning is state of being hidden from the view. Here the major advantages of continuously viewing the Sun without any occultation. Occultation means state of being hidden from the view or eclipse. This will provide a greater advantage of observing the solar activities continuously. Using the special advantage of point of L1, 4 payloads directly view the Sun and the remaining 3 payloads carry in the in situ studies of particles and fields at the Lagrange point L1. The suite of Aditya L1 payloads are expected to provide most crucial information to understand the problems of the coronal heating, coronal mass ejection, pre-flare and flare activities. This paragraph tells us about suite of Aditya L1 payloads are expected to provide most crucial information and the understanding of problems of coronal heating, coronal mass ejection, pre-flare and flare activities and their characteristics, dynamics of space weather, study of propagation of particles and fields in the interplanetary medium, etc. While coming to the Lagrange points, for a two-body gravitational system, the Lagrange points are the positions in the space where a small object tends to stay. These points in the space for two-body systems such as Sun and the Earth can be used by spacecraft to remain at these positions with reduced fuel consumption. Now we will see the Lagrange's points. For two-body gravitational systems, there are 5 Lagrange's points denoted as L1, L2, L3 and L4 and L5. The Lagrange point L1 lies between the Sun-Earth line. The distance of L1 from the Earth is approximately 1% of the Earth's Sun distance. That means the Lagrange point lies between the Sun and Earth line. The distance between the L1 from the Earth is approximately 1% of the Earth and Sun distance. 1%. Now, why study Sun from space? The Sun emits radiation or light in nearly all wavelengths along with various energetic particles and magnetic field. The atmosphere of the Earth as well as its magnetic field acts as a protective shield and blocks a number of harmful wavelength radiations including particles and fields. Due to the limited mass, power and volume of the spacecraft that carries the scientific payloads in space, only a limited set of instruments with limited capacity can be sent on board the spacecraft. In the case of Aditya L1, all the measurements will be made from the Lagrange point L1. As an example, the various phenomena of the Sun are multidirectional, and therefore the directional distribution of the energy of explosive eruptive phenomena will not be the possible to study with Aditya L1 alone. Another Lagrange point known as L5 is a good vantage point for studying the Sun, directed CME events and accessing the space weather. Also, the polar regions of the Sun are not well studied due to technological challenges of achieving spacecraft orbits for such studies. The Sun polar dynamics and magnetic fields are believed to play important role in deriving the Sun solar cycles. Further, the polarization measurements of the solar radiance at different wavelengths are required to understand the various processes occurring in and around the Sun. This is all about the voyage to study the Earth's Sun. If you like this video, please like, share and subscribe. Thank you.